Hi, my name is Victor Bart, and as you can see by my outfit, I'm a Victron professional. Not really, I just like to build this stuff, and I will give you some tips and tricks in this video because we're gonna continue building on this off-grid, self-sustaining Victron system with a big inverter for induction cooking, lithium batteries. I'm building a 1965 Unimog 404 off-road camper, and this is the electric installation. So let's take a tour what we have now and give you some information why I did it. And after that I will continue working on the system and then show you what I did today to make this system really nice and awesome. So this is the Phoenix 2000 VA inverter, and this is powering my induction stove and my high power appliances. This inverter is not 2000 watt. And 90% of the people in videos say it wrong. This is only a 1600 watt unit, and the VA rating is just really complicated. I wish that Victron just was using watts for the rating, so you can easily compare it to other brands. I placed it on his side here and it will come under the bed. Now comes the funny thing. The first time when I asked on a Victron Facebook group about mounting it this way and about the cooling options, most people said you don't need cooling, it's fine, blah 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 blah. The second time when I put pictures online where I put it like this, the comments were completely the opposite. Oh, it doesn't have enough cooling like this, and panic, and you need to put it up, right up or on his back and not sideways like this. So yeah, the internet, always good for the right information. To make sure the cooling is fine of this unit, I removed this top plate that goes here, and there are two like 9 centimeter fans here. That's the internal cooling. And I added this high quality 12 centimeter server fan with a metal core. So this is like a high performance fan that blows cold air into the inverter. And this is just a case that it is a wind tunnel. So I don't think that I don't have enough cooling. I asked a Victron installer in the Netherlands. He installed 150 inverters and multipluses. He only has 3 back for repairs. And he told me that it's fine to put it like this. It's not the recommended way, but with the extra cooling it will not die and it just runs. And if it overheats, it won't break, it just throttles down the output. So instead of 1600 watt, it will become like 1200 watt, something like that. It's hard to kill this inverter, so I will be fine like this. This inverter is not a multiplus, and a multiplus can also charge the batteries, but I measured out this spot, and also a multiplus 12-3000 can fit in this spot for future upgrades if I need to. Mounted under the bed, you can't reach the on and off button, but luckily Victron has a solution for that. That's the Phoenix control, and there's a little panel with an on and off switch and the status LEDs that's normally here. So I'm gonna install this in the kitchen, and it's really easy to cable this because there's an RJ45 plug, and you take just standard network cables to plug it in, and you can plug it into the inverter in if you remove the covers. So you can easily install it on another place in the camper with easy cabling, because you can use way longer UTP cables than this. This Victron Phoenix inverter has some hidden features. To access them you need this USB dongle. This is the interface MK3 USB VE bus to USB, and if you connect it to the inverter and your laptop and download the software, you can program this inverter and also use the relay functions or program alarms or start a remote generator, and I'm gonna explore this in a future video. This is the fuse box for the 230 volt installation. One of the fuses is for the shore power, and that goes here to 2 sockets. And the other one is the one that is in between the inverter and the electrical installation in the camper. I don't have enough knowledge about this kind of systems that I can explain it to you how you can do it. So please check it out on other websites or videos how to connect to 230 volt fuses and breakers and stuff like that. I built this part with the help of my brother, but the 12 volt system is really clear for me that I can explain how I do it. This is my Blue Smart Charger 12 volt 25 amps. So if I plug in the shore power, it directly will charge the batteries. The second fuse is for the inverter and the internal sockets, and I will not put a connection between the internal sockets and the shore power because I don't think it's necessary. If I plug in the shore power, it turns on this charger and that charges the batteries, and if I will use the internal sockets, it will just run through the inverter. Here I have a very small inverter. This is the Victron 12 volt 375 VA. This is a 300 watt unit, and you buy them for like 114 euros or something. Super cheap. So I was thinking, yeah, it makes no sense to sell this off and make like 70 euros. I will just keep it. And the purpose of the second small inverter is the big inverter I turn off after use, and this one I can connect to some sockets where my chargers for camera batteries are and like super small loads. So I can keep this on also while driving and charge laptops and stuff like that. And then the big one is off, and this one uses way less idle power than the big inverter. I already had the inverter, it's not necessary, but I like it. These are my two batteries. They are from the brand Lithium. They are 100 amp hours each, both 12 volt. And I will put them in parallel. That makes it a 200 amp hour 12 volt battery. They have internal BMSs, of course. You can open the batteries for maintenance if it's necessary in the future. And the batteries have Bluetooth to monitor them and check settings and change settings. And if you want to know more about the batteries, check out my review. I will link it down in the description. These are the cables between the batteries. They are 70 square millimeter. I like big cabling because that makes your system more reliable and less overheating in cables, so less trouble. This 70 millimeter cables will be made shorter and connected here to the batteries. It goes into an ANL fuse of 300 amps, and this cable goes into this custom bus bar here. So here will be a 70 square millimeter cable to the inverter, and I will not put a fuse between here and the inverter because the inverter already has a 275 amp fuse internally. The cable that goes to the inverter is also directly fused by the main fuse. So if I got troubles with that cable, this fuse will blow and then the system is safe. This 25 square millimeter cable will go to this fuse box, and I will tell more about this later because I think it's one of the best affordable fuse boxes. This is my Victron shunt, and you use that to monitor the power use of the batteries. You can log into the batteries and use Bluetooth for that, but then you have only the information about one battery, and this one measures it just how much power is used, and you can monitor it on your phone. So probably if the system is fine and works great, you never have to check it, but it is good to have some information about the status of your batteries. So from this terminal I will make a cable here to the battery minus on the shunt, and to connect the shunt to the rest of the system I will make a cable from the system minus to the bus bar, but I gonna install a switch in between. If you see modern schematics, you see the main switch always in the positive part of the system, but I gonna install it in the negative part of the system. When I showed that earlier, I also got a lot of comments of people, oh, it's wrong and blah blah blah, and then the experts backed me up and said it's totally fine, it's just another approach, and also the Unimog is switched like this on the negative side of the power system. So yeah, it's just an older standard and it works fine, but please follow your own schematics and make your own plans, because what I'm showing is not what you should do directly. You should make your system custom for your needs. This fuse box is absolutely awesome, cheap, and it's a Victron product. It uses mega fuses and M8 bolts, and the rating of this unit is 250 amps, so it's not for the big inverters, but for the rest it's an absolutely awesome system. And it is so awesome that I just bought a second fuse box like this. And you see a bus bar here that connects 5 terminals, and you have one terminal free, so you can use this, for example, for something else or for a different voltage in your system. But I would prefer if this bus bar was just 6 and that there was a line here where it says cut it here if you want to have this separate. But for 35 euros you can't complain, so I just made an extra bus bar that connects the 6th fuse to my system. And I will put Amazon affiliated links down in the descriptions of all the products you see, so you can check it out and pick it up and support my channel by doing that. But this fuse box, really pick it up, it's amazing for the price of 35 euros. This 40 amp mega fuse is for the small inverter. Then I have a 100 amp fuse that goes to this 25mm that goes to the Unimog 12 volt installation. The 40 amp fuse will be for the solar controller. Then a 60 amp fuse for the DC-DC converter. And then two 60 amp fuses that probably goes to smaller fuse boxes for the small fuses. This is my crown bus bar. I got it for free from a Dutch self-builder that had it as a leftover. It has 9 M8 bolts, and it's not for the high power current of the big inverter, but for the smaller loads from 40 to 100 amps. This is perfectly fine. And the way how I mounted it is that it corresponds with the fuse. So the negative goes on the bottom, and then like here the positive will go over it, so it doesn't take too much room and it makes the system looks really nice. And one person online was afraid that this cable could touch this bolt, but as you can see I can put my fingers in between and there's more than enough room, and the cables are really like stiff here, so it doesn't move around. And if the positive cable will touch the ground bar, the fuse will blow, because fuses are also made to protect the cables. So this is a 25mm cable, and a 100 amp fuse protects that. So the 60 amp fuse is for 16 square millimeter cable, and you can look that information online, and you should really make a plan that you fuse all your cables. And I see so much systems online with cables that are unfused, but the only exception that I will make in the system, that is this cable. This is 25mm cable that goes to the main bus bar and that goes into the fuse box. I will not fuse this with a 100 amp fuse. I don't think this will give any problems, and if I would just put a 70 square millimeter cable in here, the main fuse would secure it. So I think if this gives a problem, the main fuse will blow anyways, but maybe the cable will heat up a little bit more. But I have a lot of plastic clips here, so I secure all my cables with these plastic clips and a zip tie to the walls, so no cables can move and everything stay in place. And I bought like 300 of them, so I can use them everywhere where I want, and they were like 8 cents each, but makes the system really sturdy. As you can see here, the cables won't move and are nicely routed. For the smaller fuses up to 30 amps, I was using this style of fuse box. It's really good, it has a cover and it's just good build quality. Only every fuse will get his own cable, and you need a separate power distribution for powering this. So nowadays you have way fancier fuse boxes like this, even with control LEDs to see if a fuse has blown. So this is from Tiger Expat, a 12 fuse unit. Even you can put spares in here. It has a ground bus bar built in, and this is like 40 euros and really high build quality. So this I will use for the main distribution, and I even bought 2 of these units because I like to fuse everything and add all kinds of options in the Unimog. The Unimog is 24 volt, the camper installation is 12 volt, so I'm gonna install a DC-DC converter from 24 to 12 volt to charge the batteries while driving. And I'm gonna install this fuse box. It's way flimsier than the Tiger Expat fuse box, but this is for the 24 volt that comes into the camper. And I chose to have the 12 volt in the camper because if you use thick enough cables it will be fine, and then you don't have 2 separate voltages here in the systems, so it's less complicated. Only, for example, a solar controller on 24 volts can use double amount of solar panels. So it's an all other discussion. It's just 24 volt for the Unimog, 12 volt for the camper here. So I'm gonna install this fuse box. So 24 volts will go in, 1 fuse will go to the DC-DC converter, and the other 5 fuses are for extra things. I have nothing planned right now. For example, I can put a relay on it, so if the 24 volt is on, I can switch a fan on, or a fan behind the DC-DC converter, so if it's get power, it will be cooled. And I'm not yet sure if I'm gonna use this ground bus bars, or I will make my custom bus bars with these strips with a lot of bolts. This strip has 25 bolts and this one has 19 bolts. So this will make like a super great bus bar in the whole electric installation in the camper. Yeah, options, that's good to have. The 24 volt fuse block is now installed, and I made this cable to power the fuses here, and I made this panel here for my solar and DC-DC charger with cooling fans. So let's take the panel out. So we have my DC-DC charger and my solar charger, and on the rear 8 cm computer fans. So if I need extra cooling on hot days, I can turn on the fans and I directly blow the air on the heat sinks. And this 12 cm fan, that is for the extra cooling in the whole area here, and also to cool the inverter, because it will draw in the cold air, put it in this box, and then this fan here will draw the cool air to the inverter here. And I made extra holes here for the cables, like this 70mm cable, because the main switch comes here in like an inlay in the interior, so you can easily turn off your whole system and the solar from outside this box. So I need to add an extra hole here for cables and little things like that, swap this fan to here, install the fan cards. And so far I like this solution. I was really thinking about it, how I could solve the issue of the extra cooling, because when you cool them extra they perform also better. So that's always a bonus to get like 10% more performance out of the units on warm days. Please check out the description if you want to know more about the parts that I used. Also, you can directly buy them on Amazon if you would like. And please check out and pick up this mega fuse box, because it's awesome. And for 35 euros, it's so cheap, and just add a bus bar and you have like a perfect solution for your DC converters, solar controllers and medium-sized loads. If you like to support me, you can check out my Ko-fi page or make a PayPal donation. And thanks for watching.